And now, the moment we have all been waiting for, a keynote lecture by none other than Mr. Vitalik Buterin. He is the creator and co-founder of Ethereum and chair of the CCTF Advisory Committee.
Okay.
Vitalik's pioneering work has shaped the blockchain landscape as we know it today. Without further ado, please join me in welcoming Vitalik Buterin to the stage.
Okay.
Oh, welcome.
Thank you. Okay, no, sorry. Yeah. I think we need to set the gas fee on this thing higher. Yeah, so, okay. Okay, perfect. So I think the most important fact about the crypto space this year is basically that this year is really the year where we've turned the corner on crypto and the underlying technology, getting to the point where we can actually do all of the things on top of it that we have wanted to do the whole time. So I think if you think back to 2013, right? Who here remembers like some of the early Bitcoin days? Like who here remembers either back in 2013 when we had stores that were like people trying to get physical stores like restaurants trying to accept Bitcoin for payments? So, okay, great, story time. So here on the left, this is a bar in Berlin that was called Room 77. It's in a district of Berlin called Kreuzberg. And there was an entrepreneur named Jörg Platzer who runs this bar. And he decided to make a project out of going around to all of the restaurants and stores in his neighborhood and trying to convince as many of them as he could to start accepting Bitcoin. And he actually succeeded. He got like about at least 11 places, I think quite a bit more, all within about 1 kilometer of each other, I think even like 500 meters, to accept Bitcoin. There was this small region of Berlin where you could just go and you could do basically everything with Bitcoin. And this actually kept going for quite a few years. Over here on the right, this is a store in Boston called Thelonious Monkfish. And very similar, like the store owners just themselves decided like, hey, Bitcoin is cool, let's try accepting Bitcoin as a means of payment. Right, back then there was this like really deep excitement about Bitcoin becoming the great next world currency. And if this is the new money, let's like actually try hard to get people to adopt it. So in 2021, I remember visiting Argentina for the first time. And in Argentina, I remember one of the first things that I noticed is just about everyone there is using crypto. And they were not just using crypto for like open source, libertarian, ideological reasons. They were using crypto because like they really need it, right? The local currency, on average, has been depreciating against the dollar for the last 5 years, about by a factor of 2 every year. The country has been averaging like 30% inflation for, and that's an average across literally the entire last century. People just need some form of savings. People need some form of stable value to send and to use for regular business transactions. And one of the things, though, that I noticed here is that they were using crypto, but they were not using the blockchain. So I actually made a point of paying people here like actually with transactions on chain. So this was when I was walking around on Christmas Day, and the first coffee shop I found that was open. I walked in, the owner recognized me, and I asked if I could pay in ETH, and he said that I could. So he had a Binance wallet, and well, the thing that they're used to is Binance to Binance transfers because they're free and instant. For me, I decided, well, I'm from the Ethereum chain. I need to actually use the Ethereum chain, and so I paid. The transaction fee was about like somewhere between like $2 and $7. The transaction took about 5 minutes to confirm. So a similar thing ended up happening to all of these Bitcoin accepting stores, right? The fees of Bitcoin were extremely low back in 2013. And if you look at how Bitcoin got advertised in 2013, people were like very insistent that one of the most important things about Bitcoin is that its transactions are very cheap. The banks, the credit card companies, and PayPal, they screw you over. They charge 2.9% plus 29 cents on a transaction, and then the fees are 3 times higher if it's international. Western Union charges like 10%. Crypto, basically free. Well, what happened? Transaction fees went up to like about more than $10, more than $50. At one point, for the highest transaction fee I ever paid was actually $800. And this was, this one, the transaction took a lot of gas. It was like somewhere between like 500,000 and $1 million gas because it was a privacy-preserving transfer. But still, $800. So fees got too expensive, right? And the reason why fees got too expensive is because the chain had a fundamentally limited capacity, right? So people wanted to do, for example, like Twitter on the blockchain, right? And let's think about this question. Like, what would it take to do Twitter on the blockchain? So does anyone here like wants to just like estimate how many times they've tweeted in the last week? Anyone shout a number? 100, okay. 100's a big number. Any other number? More than 20, okay. So we'll average and we'll say 60. So 60 times a week, 60 divided by 7, 8.6. So 8.6 tweets a day. Let's say you wanted to make Twitter on the blockchain with 100 million users. 100 million users becomes 860 million tweets. Just conveniently, there's 86,400 seconds in a day. And so if you divide, to do Twitter on the blockchain, you basically need 10,000 TPS. How many TPS does Ethereum do? It does about somewhere between 10 and 50 TPS, at least on the L1, depending on the complexity of the transaction. If it's just Twitter, the transactions will be simple, so like probably closer to 50. But still, you have 50, you need 10,000. So anytime any application even started to be successful, often that application by itself would cause Ethereum's fees to go up and the whole thing would break. This is what happened with CryptoKitties. This was then. Now let's think about what's happening now. This is a chart of transaction fees in 2024 on layer 2s. So layer 2s are the primary scaling solution for Ethereum. They're networks that are not directly on Ethereum, but they are attached to Ethereum. They're connected to Ethereum in a way that allows them to inherit the security and all of the other important properties of Ethereum. But at the same time, they do not require every Ethereum node to actually do all of the computations. And because of that, they can be much more scalable. Now, roll-ups are the main type of layer 2 network. And roll-ups are limited by the fact that even though computation happens off-chain, a significant amount of data still has to be put on-chain. And so they're limited by the amount of data. Now, in March of this year, we did a hard fork called Dencun. And in Dencun, we added this new feature called blobs, which adds 384 kilobytes every 12-second slot of extra data space for rollups to use. Now, this extra data space greatly increased the scalability of rollups, and it allowed rollup transaction fees to decrease from between 10 and 50 cents to under 1 cent. So who here would be willing to use decentralized Twitter if it cost you 50 cents every time you had to tweet? No hands. Who here would use decentralized Twitter if every time you had to tweet, you had to pay half a cent? Okay, more hands. Now, I counted about 6 hands. If you take the whole population, this looks like somewhere around 500 people, multiply by 1.2%, extrapolate to the whole world, 8 million times 1.2%, 96 million users, so, great, we win. So even still, right? Basically, at least this, obviously, getting fees to be low is not the only problem we have to solve, right? We have to solve UX, we have to solve go-to-market, we have to give people an actual reason to use decentralized Twitter, right? So, but if the fee problem is not solved, none of the rest of it can be solved. And the big thing that happened in 2024 is that the fee problem actually did get solved. That's not the only thing that happened. Another thing is, let's look at transaction waiting times. When you send a transaction, how long does it take for the transaction to be included on chain? Bitcoin, 1 block on average every 10 minutes. Often you have to wait like 60 minutes or longer. Ethereum, a block time with proof of work, theoretically it was 13 seconds, but in practice, because of the inefficient fee market mechanism, often as a user you have to wait anywhere between like 15 seconds and like maybe 10 minutes. Now, Ethereum post EIP 1559, which greatly increased the efficiency of the transaction fee market, and post merge, which switched from proof of work to proof of stake, the waiting time actually went down a lot. If you use Ethereum, if I use Ethereum today, you only actually have to wait like usually about 5 to 15 seconds for a transaction to be accepted. And so back then, when I was first visiting Argentina, actually EIP 1559 had come out, but most wallets had not yet actually integrated it. And so when you pay for a coffee, like you actually have to like often wait 5 minutes. Today, you do a similar thing, and the waiting period is actually not more inconvenient than the waiting period when you pay with a credit card. So I would say, waiting time problem basically close to solved. Now, we could also look at general application user experience. So on the left, you have decentralized Twitter in 2015. On the right, decentralized Twitter in 2024, right? So massive improvement in quality of UX. So well, the point of like all of these things put together, right, is basically that if you think about like what would it take for an application using a blockchain to succeed, then no matter how well you do on every other front put together, no matter how well you do on product market fit, no matter how well you do on marketing, no matter how well you do on getting crazy celebrity influencers to shill your thing, no matter how well you do on just like actually being useful, like if you're stuck on a blockchain which is bounded at 10 TPS and which is incredibly hard to use, you're going to lose. This is the single big factor that's basically killed applications up until this point. This year, that factor is gone. This year, the gates are opened. So welcome to the decentralized future. But now, we have to actually build things, right? So I think the first 10 years were focused on the basic technology and making sure that the actual infrastructure actually had the capability to do all of the things that we want to do on top of a blockchain. Now, we basically have that capability, and the focus needs to switch to, well, what do we actually use that capability to do? What kinds of things are we actually going to build? What actually uniquely makes sense to build on top of a blockchain? So I think basic payments and finance continues to be an important use case, right? Basic payments was the first app. Payments continues to be one of the most important apps. International payments, especially, I use crypto to do international payments all the time. When I can, it's massively more convenient than doing bank transfers. And there's a lot of people around the world who often just don't even have the kinds of access to basic finance that we do. So continuing to improve finance, like including the ability to save and grow your wealth, and including the ability to just pay people and actually use it. I think these are both things that are just going to continue to become an important category of applications. And like these are the things that are already succeeding today, right? There are entire countries where more than 10% of the population holds cryptocurrency. Often, like these are countries where the political environment is like the most unstable, right? If people were using cryptocurrency just to gamble, then like it doesn't matter what the political environment is, right? It's like good currencies, like, you know, they're stable, bad currencies, they're kind of stable. But in this case, like the common pattern, right, is that the countries that have become the most famous for having very high adoption, like they don't have a stable internal financial system, they don't have a stable internal economic system, they're not well connected to global infrastructure, they're places where people like really actually need an alternative. And blockchains are proving to be actually good at providing it. Now, historically, of course, this stuff has been happening, but it's been happening inside of centralized wallets and centralized exchanges. The problem with centralized exchanges, of course, is they can be hacked. Their owner can turn out to be a crazy guy that gambles all your money away. All kinds of things can happen. So blockchains are, a much better solution, and decentralization actually does make things safer, right? The challenge is, can we make decentralization practical? And with the technology of today, we finally can. So this is a wallet called Dymo. So this is, it's basically deliberately intended to be like competitive with Venmo and useful with the same quality and standard of user experience that Venmo has, but under the hood, it's using stablecoins for transactions. So I expect that we're going to see many more things that look like this. Decentralized social media. So decentralized Twitters. So we have Farcaster, it's a decentralized Twitter. We also have Lens. So actually 2 big decentralized Twitters on top of Ethereum. More and more people actually using them. Now, prediction markets are another one of those interesting areas, right? So a lot of people have been like following prediction markets for a long time, right? And a lot of like intellectuals have been very interested in them. So Robin Hanson, I think, from George Mason University, has been talking about them as an idea for a long time. And he came up with this idea of futarchy, which basically says to use prediction markets as a form of governance. So basically, what you can do is you can make conditional prediction markets that basically say, well, if we do this, then predict what will happen. If we do something else, then predict what will happen. And you actually look at both predictions, and then based on which predictions you like more, you actually you make that decision. Now, all of these ideas have been very theoretical for a long time, right? And they just have not had sophisticated participants. They have not had market volume. You need market volume to attract sophisticated participants. And like historically, they haven't performed too well. This year, I think, has been a year of like really massive growth for them, right? So Polymarket in particular, it's just grown massively this year, both in terms of volume and, at least from my own observation, in terms of the quality of the participation on it. So what's interesting about prediction markets to me, right? To me, prediction markets are basically a different kind of news service, right? So on the internet, anyone can go and say things. And if you can go and say things, like people will just go and say all kinds of things. People always say things in every single different direction. And it's hard to tell, like if someone says something, like, does this actually matter? Should I actually listen to them? Is this actually meaningful, right? And I think prediction markets actually can be part of the solution here. So here on the left, this was a couple of months ago, there was a tweet by Elon Musk, basically in response to like people complaining about UK immigration, and Elon replied and he said, civil war is inevitable. Very soon, a prediction market popped up on Polymarket, basically asking, what is the probability of a civil war in the UK in 2024? The market said 4%. So then I actually thought 4% is too high. So I actually came in and I put a bet myself. And so I think I'm responsible for like one of those declines somewhere in there. And then now it's down to 3%, and I think now it's even down to 2%. So basically, anyone can say things, but the situation becomes very different when you actually have to put your money on the line, right? And like a lot of the time, like I've noticed that even like their mainstream political intellectuals, like even the types of people who think crypto is useless, crypto makes no sense, although there's no point to decentralization, even they end up retweeting screenshots of Polymarket. Now, to me, this is like only the first example, right? Just like you're saying what will happen and telling people to make bets, this is like the simplest possible use case. I actually think most of the social value comes from doing more interesting and more complicated things. So we could do things like conditional prediction markets, right? Basically, you can have a prediction market that says, what decision will some organization make? And then if they make this decision, then what will some particular outcome be? And you can then look at those probabilities, and then you can start to use prediction markets as a way to see what might the consequences of certain decisions be. And there are actually already existing like examples of like some specific markets on Polymarket basically already being usable for this purpose. Another category that's interesting is micro prediction markets. So if someone wants to ask a question, like any question at a very low budget, and this could be any question, right? One particular example that I'm interested in is basically like very low cost dispute resolution. So if you have any kind of subjective question, right? So for example, let's say someone made a tweet and all you want to ask is like, is the statement in this tweet true or false? Right? A group of humans could make a reasonably good answer to this. But a group of humans takes a lot of resources to bring together. You have to pay them. They have limited time. And so you cannot do this for every tweet. But here's what you can do instead. What you can do is you can make a prediction market that says, well, if we did bring a group of humans together to decide, then how would they answer? And what you can do is you can make this prediction market, and then instead of humans playing on it, you can have AI playing on it, right? You can have LLMs that just, and anyone would be able to join the market, anyone would be able to participate, and then like basically you would create a game where over time the best LLMs would be the ones whose predictions actually do match what the humans actually say in the like randomly selected portion of the time when humans actually get called in. So if we basically any kind of mechanism that is where you have some mechanism that is high accuracy but which is slow and expensive, you can basically use a prediction market and have LLMs play in the prediction market, and you can make a kind of distilled but much more efficient projection, like simulation of that mechanism, which is going to be good enough for at least some percentage of tasks. So I think this is like one of those use cases that's interesting, right? So this gets into this other big question, right? Which is what role should AI play? I think lots of people talk about like AI blockchain intersections, right? And I feel like there's a lot of people who like understand this question on this like very surface level, right? Like to me, like level 0 is basically AI is cool, blockchains are cool, therefore AI blockchain is cool squared. I think you could go, then, you know, you could go one layer higher, right? And you can say things like, AI is powerful, but it's the technology of centralization. It has monopolies. It's not transparent. Blockchains are the technology of decentralization. And so maybe if you can combine them together, somehow you can like get the best of both worlds, right? And like a lot of people do make this point. But this point is like a very sort of like high level thematic kind of point, right? The challenge is like, how do you take that? How do you actually like translate that very high level point into a specific concrete thing that actually uses AI and blockchains in a specific way that actually solves for like some specific weakness of using only one or only using the other? And I think a lot of answers to this don't make sense, but I think there are a few answers that do. So I wrote a blog post near the start of the year where I outlined 4 categories of AI and blockchain interactions, and I call them AI as a player in the game. So this is basically where you have a blockchain smart contract application that defines the rules of the game, and then AIs play within the rules. And AI prediction markets, I think, are like a great example of this. One example of this that's actually been around for over 10 years is arbitrage bots trading on decentralized exchanges. Like that is one AI crypto intersection use case that has existed like basically since like at least 2015. So that's AI as a player in the game. AI as an interface to the game. So you can have AIs that help users interact with the blockchain world. You can have AIs that help users understand like what are the things that they are interacting with. If they perform a particular action, what are the consequences going to be? What are the risks going to be? What might the security risks be? Then you might have AI as the rules of the game. So actually creating an application where the AI actually like plays some kind of direct role in like top level decision making. So like being an oracle or something similar. AI as the rules of the game, I think, is something that's fundamentally much more dangerous, right? The reason basically is that basically if an AI model is open and transparent, or sorry, if an AI model is closed and like opaque, then you have to trust it. You have no idea whether or not it's actually been trained correctly. You have no idea if it's being run correctly. If it's open and transparent, you have the adversarial attack problem. People can download the model, people can use gradient descent, and they can locally train optimal attacks to try to trick the model into doing whatever they want. Someone even did an experiment a couple of years ago where they managed to optimize like a mask, like a physical mask that you can wear on your face, where if you go around, like a certain type of security camera will either think that you're not a person, or it will think that you are some different person. So adversarial attacks are scary, right? And so I think if you want to do like AI as rules of the game, there's a lot of these like big challenges. And I think in this case, not blockchains, but okay, let's sorry, not okay, fine. Next slide there. Not blockchains, but cryptography can help, right? So in particular, ZK snarks, MPC, FHE, like that whole category of things. So basically, you could have maybe the inference process, maybe the training process have stronger properties in terms of verifiability, in terms of trustlessness, than you can do otherwise. And one of the interesting things about AI and cryptography is that in AI, it's computationally expensive, but almost all of the computation is matrix multiplication. Matrix multiplication is linear. And linear operations are generally much, much faster and much lower overhead to accelerate or to do cryptographically than any other type of computation. So someone figured out a way to do like linear, like matrix multiplication in MPC with an overhead of like less than a factor of 6. Now someone has managed to ZK snark an entire AI like LLM computation where the overhead is, I believe, about 110x. Now 110 is a lot, but if you compare to any other computation, ZK snark overhead for most regular computation is going to be like 10,000x. So already pretty massive improvement here. So potentially there is an opportunity to try to get the overhead of the cryptography actually low enough to the point where you actually can do AI computations cryptographically in such a way that like you can do things like decentralizing models, preserving privacy of data, preserving privacy of the model, getting integrity about the training process in a way that where the overhead is low enough that like it actually is competitive compared to just like basically making a much simpler model and just running it locally on your laptop. So I think this area is also interesting. Now, one last area that I think is interesting to talk about is a return to enterprise applications. So who here remembers the era of like permissioned consortium chains from like 2014 to 2019? Okay, a lot of people remember it. So the core insight behind the attempts to do permission consortium blockchains is basically that like you have this technology which is very decentralized, but it has scalability problems, it has potentially like privacy and regulatory problems, it has these problems. And you have existing workflows that are centralized, but they're too centralized, and so you have silos. Maybe if you figure out a compromise between centralization and decentralization, and you create some kind of structure that's like somewhere in the middle, then you can make something that actually really works for like a large scale and regulated enterprise applications. The problem is that I think permission blockchains in particular ended up being the wrong compromise. Basically, I think they ended up being too centralized to benefit from decentralization and decentralized enough that you don't get the convenience of centralization at the same time, right? Basically, as soon as you go from one node to even 3 nodes, you have to worry about like networking, you have to worry about PBFT, you have to worry about all kinds of asynchronous stuff, latency, you have to worry about like a whole bunch of different things. And But at the same time, if you have only like 3 nodes or 30 nodes in a network, then the problem is that like when your consortium starts, the first few people who come in, they might trust it, but then it turns out that it's hard to scale it further, because once you scale it further, it just gets perceived as being something that's controlled by whoever the first group is. So I think now we have ZK Synarchs, and in particular we have ZK layer 2s, especially Validiums. And I think we now have an opportunity to actually go back to enterprise blockchain applications, but try them a different way. Instead of creating permissioned consortium blockchains, we embrace the public chain, but we embrace it as a base layer. We do not put all of the data on the public chain. Instead, we publish only the hashes, only the roots of the data onto the public chain. Everything else can still happen even in a server. You can keep your server, you can keep the exact server-based code that you have, you just add a little bit extra on top to publish hashes to the blockchain and to publish proofs to the blockchain, proving that whatever updates you're doing, you're actually doing them correctly and you're following the rules that you said that you're following. So if we do this, I think like this is actually a compromise between centralized and decentralized approaches that might actually work much better and be much more viable for a lot of different applications. So summary, right? Basically, I think the technological fundamentals of the crypto space are brighter than ever. So many things have massively improved this year. It's a night and day difference using the ecosystem today compared to 2 years ago or 3 years ago. There is, I think, lots of consumer and public demand for the underlying ideals of building global, open, and trustworthy systems. There are lots of people stuck in areas where financial systems just don't work well. There are lots of people who want alternatives to Twitter. There are lots of people who want alternatives to in centralized identity systems. There are people who, there's lots of demand for some kind of more open and more decentralized alternative to the way that AI is turning out right now. So there's a lot of demand for these things. The challenge is that like crypto, the set of ideals, has always met this demand, but crypto, the set of technologies, historically has not been strong enough, right? And we need to like actually continue improving the underlying technology, and we need to actually build these things because the base layer actually is strong enough, right? But if we want these applications to succeed, then the entire stack needs to be. Thank you. Yeah, thank you.
We have time for a few questions.
Any question from the audience? Roger, you want?
So, Vitalik, thanks for talking a lot about the history of decentralization, how much decentralization is, how much AI can use it. So I think you also mentioned a lot about the challenge about AI. So I have a question that I think I asked you earlier, but maybe I asked in a different way. It's AI right now. You say there's a lot of problem for transparency, but if it's fully transparent, people can manipulate, right? So then, and also right now, decentralized AI is really hard because the training large language model. So what do you think about how decentralized AI it is? It can be actually used in the blockchain system, as a player or as a rule, or maybe even like, how, I guess like, how do you think about AI could potentially be play a very important role to help the ecosystem?
So like, how do you think AI could be used? Like, what's more specific, sorry?
Maybe like right now, you mentioned a lot of problems with AI, right? Yeah. Do you think like maybe give it like last time you say 5 years from now, the ZK will be used? Do you have a prediction? Like when do you think like maybe 10 years from now, do you think AI can play?
I mean, I think it's very hard to make predictions about AI, right? Because like if you try to make predictions in 2019, then like you would be completely wrong, right? If like AI has just proceeded so much faster in the last 5 years than almost anyone was expecting. Now, if on the other hand, you made predictions in February 2023, then like maybe you would actually predict we'd be further ahead now than we actually are. right? Then if you look at the details of like what the latest ChatGPT like 01 actually is, it's basically not really doing that much innovation on the training side. It's not upscaling the model, and instead it's basically like fine-tuning the model to do chain of thought, and the big difference is that it's doing a lot more compute at inference time than it did before, right? So like the fundamentals often change very quickly in all kinds of different ways, right? So I think it's hard to predict what will happen. I think the best that we can do is like try to create more different options for what can happen, right? So like, for example, if you take the idea that I had of using like micro prediction markets to do like even like fact checking in social media, right? Like if you don't, like the natural centralized alternative would be to say, we have one model and that one model does everything and you have to trust it, right? The problem, of course, is that like there's no single model that the entire world, and in many cases, there's not even a single model that an entire country is going to trust, right? And so like you're basically creating this like you're relying on the company itself to be like both this point of trust, and you're also relying on them to be like both a good social media company and also be good at the AI thing. If you make this kind of decentralized prediction market architecture, you've basically turned it into an open market where people can come in and participate, right? And then you have like an actual like panel of humans like providing the ground truth, and so you're kind of aligning the market at the end, but like it's still an open system, right? So like that's one particular example of an alternative. I think another example, right, is I mean, we talk a lot about like these fancier kinds of decentralized AI. I think it's always valuable to remember that the simplest and most natural kind of decentralized AI is AI that just runs on your device, right? No ZK, no MPC, no FHE, just like download the model and just run the model locally. You know, no cryptography, easy, nothing to security audit, just like except for the operating system itself, like maximum safety, right? So I think another path is if you actually can have more models that are like models that are very powerful, but at the same time they can actually run locally, right? And then there's maybe a question of like, well, how do you actually go and create these models? Then like, how do you fund them? Could you potentially pay people for data? If you're paying people for data, then how are you ensuring that you're actually getting good data instead of people making fake data to get money? And like maybe the cryptographic parts can actually help with that, and you might have some kind of 2 of 2 MPC thing. So I think like that's another category of different questions and possibilities, right? Another possibility is like, if you take something like WorldCoin, right? Like basically it has AI models that detect in person whether or not some particular, like the thing that it's looking at is like an actual person, or if it's like a fake mask that's designed to look like a person. One of the things that they want is they want that like design to be as trustworthy as possible, right? And the question is like, well, is it going to be a design where everyone just has to trust the company, and maybe if they get hacked, then like they're going to have 50 million fake people without anyone ever realizing, or is it going to be something that actually can be trusted? So like the better that we can figure out some of this like privacy preserving AI training and inference technology, the more we can actually start like shifting things toward that second side. So I think there's like a lot of little examples that we can try to push forward more, but at the same time, yeah, it's like incredibly hard to predict all of these things ahead of time.
Sure, thanks. Yeah, this gentleman.
Good morning. Yeah, thanks for sharing some information for us. And I have a question. Every year there's some blockchain coming out and they say they will Ethereum killer. And I heard that Tron blockchain, they will have a wonderful function in Q3. And
wait, sorry, do you mean Ton or Tron?
Tron.
Okay, Tron, because I think they're both Ethereum killers.
Yeah, and I heard that they will have no transaction fees in Q4.
Okay.
And I think it will be more convenient for us to transfer the USDT or the USDC in Tron blockchain. And right now, when we use transfer in the Ethereum, we still need the ETH as a gas. So what do you think about these functions of in Tron blockchain? Because it will really the game changer, or it will really the Ethereum killer? Thank you.
I mean, I think that stuff was a much better argument back in like 2021 and 2022, right? Because back then, like basically if you go and look at like any developing country and you look at how they're using crypto, it's like basically USDT on Tron. Why? Because it has low fees and it's cheap and instant, right? I think those are exactly the problems that the Ethereum ecosystem today has actually solved, right? Like if you go on, like Arbitrum, like Base, any of these networks, transaction fees are reliably under 1 cent, right? And there's increasingly more and more tools that you can use where like as a user, if you don't have any ETH, then you can go and you can just use USDC or USDT to pay the fees. And if you don't want to pay fees at all, there's like some cases where there's wallets that are willing to cover some number of transactions for free for you, which is easy to do because like the fees are under 1 cent and it's really not hard to cover them, right? So I think it's value, like those all of those arguments against Ethereum, like those are examples of like things that were much more true in the past than they are true today. And I think like a lot of the market doesn't even realize the extent to which they're not true yet, right? And so I think like one of the tasks for all of these like layer 2s and wallets just is to do like the education problem, right? Basically that like, hey, layer 2s actually are extremely close to free now, and they actually are competitive with these networks, and they're providing like TPS that's on a level that's competitive with these networks. And I think over time, more and more people will catch up to this.
Okay, so this gentleman?
Yeah.
Hi, Vitalik. It was really interesting about the enterprise systems. One of the things was transaction speed as well as the cost, which you talked layer 2 onwards. How are you seeing Ethereum really enabling this, this being done like in the ecosystem, being the preferred choice for use case?
Sorry, how do I see what?
How do you see Ethereum being used as the preferred choice in enterprise systems for all kinds of transactions? Because there are millions of transactions being done, and we were looking at different types of blockchain to be utilized. But now, what you've spoken about with layer 2, there's a lot of inherent advantages present. How do you see Ethereum as an organization itself enabling the ecosystem?
Sorry, I'm still trying to,
I'm trying to, because becoming the point of like, how do you enable the ecosystem within enterprise systems to be actually using Ethereum in a lot more progressive manners?
Yeah, so he probably asked what are the reasons or what are the things the Ethereum ecosystem can do collectively to enable more applications
right.
out of Ethereum.
Right. Yeah, so I think the part that's been solved, right, is basically like fees and all of these issues on a technical level, right? So on a technical level, like if you have an application that's like high value DeFi, then like it still makes sense to do it on L1. And actually, because of all of the, like there's more space for L2s, L1 itself has actually also gotten quite a bit cheaper, right? And so the part of the problem that's been solved is like the raw technical part, right? The part that still needs to be worked on more is the part that has to do like user experience and developer experience and like actually making all of these things properly accessible to more users, right? Because, so like for example, wallets over the past year have improved to the point where like you don't have to manually switch networks, right? But like a lot of people still aren't like even aware of this, and like there's still wallets that haven't quite upgraded, right? Or like the technology for moving assets between one layer 2 and another layer 2 have not yet been good enough. For the enterprise case, I think one thing that's very valuable is I think there need to be like basically ZK Validium as a service providers. Like we need to have a bit like businesses that specialize in basically talking to a big company and saying, okay, you have an application, you want to put it on chain. Let's look at your existing setup, and you can keep your existing setup, and we're going to add this like extra sidecar on top, where all it does is it hashes your database, it does proofs proving your computation, and it puts them on chain, and then like it makes proofs actually accessible to individual users in a way that's useful, right? So like you can they would actually be able to like go and talk to FedEx, and then like they would actually do the whole thing end to end, and then FedEx would actually be committing Merkle roots to Ethereum with proofs, and individual users would actually have like a website they can go to where they can put in a tracking number, and they can like actually get the Merkle bridge for the tracking number, and then they can go and like use that as collateral in Aave or whatever, right? So like that, like I think that kind of like full stack solution is something that actually, like someone needs to go and build it. And I think there is a lot of will to build it because there was a lot of will to do these experiments back in 2014. I think there's just a need for a lot of education to help people understand what the new wave of technology is and what kinds of properties it offers that are like vastly better than what was offered 10 years ago.
Right.
Thanks, Hi, Vitalik. Good to see you again. So you mentioned like a Dankun upgrade and blob application. For sure, like it significantly improved the gas fee. However, on the other hand, the first layer they got it was basically after block application, most of the layer 2 doesn't need to pay too much gas fee to layer 1, right? So in that sense, in the long run, what's your thought? Like how layer 1 is mainnet capture the value created by layer 2? The other related question is like last time when we talked, you are very caring about like the layer 2 interoperability, right? So in your mind, what's the best way to coordinate all the layer 2s, and how do you think like either the community or ETH Foundation can push things forward toward that direction? Thank you so much.
So I think there's like basically two strategies for there's like three strategies for ETH value accrual, right? So one of them is basically to make ETH just continue to do a better job of like just being like the base asset across the Ethereum ecosystem, right? So layer 2s generally, like at least have gas fees that are denominated in ETH, which is good. You have applications that are accepting collateral in ETH, and like ETH is accepted as a default across the ecosystem. So I think like those things are good, but like a big part of it is like basically just like marketing, right? Like a lot of people, I think, for example, like they have the mentality that like, for example, proof of stake is inherently much more centralized than proof of work. And like they don't even see, like the actual numbers, where if you look at like, for example, staking pool concentration, it's like actually much lower than like proof of work concentration, like either of Bitcoin or of like what Ethereum was before the merge. And, or even if you look at, like, for example, Ethereum's numbers in terms of client diversity, like Ethereum is basically the only large blockchain ecosystem where there is no single client that has more than half of the network market share, right? And a lot of people, like the closest is like Geth on the execution side, which like depending on how you measure is like somewhere around exactly half. But then if there's like a bug between Geth and other clients, what that means is that the chain actually stops finalizing, right? And you have two different halves. And so users that wait for finality, they're not going to see any blocks get accepted. And then that gives time for core devs to actually come and fix, right? So like these are security properties that other chains do not even have, right? And so like the value of ETH, the asset, like the value of assets as store of value, a lot of it comes from safety and trust. And I think there's value in like both like pushing to get it more ETH, more used more across these the ecosystem, and also to just like talk more about these like really positive improvements that have happened on the decentralization and safety side, and continue to do like the hard work to keep improving that. So that's one part of the answer. Number two is like layer 2s can do more to like support value accrual to layer 1, right? So, I mean, like based rollups are one example of this. I mean, I don't think every rollup needs to be based, but I think there's a valuable role for them. And basically, yeah, based rollups, they outsource sequencing to layer 1, and so that they outsource MEV to layer 1. But what you get in exchange is you benefit from the layer 1 censorship resistance properties, right? Which, like today, just basically means proposers, but in the future it will mean inclusion lists, and there's like an entire roadmap for how to make the inclusion list feature very powerful. And so, the censorship resistance feature is super useful because if you think about like DeFi liquidations, for example, right? It's like if you have prices moving quickly, if you can censor people for like even 1 minute, then you can often like steal a huge amount of money from their collateralized positions, right? And so having something where you have like a guarantee of being included even on the order of 1 slot is it's like a super powerful feature, right? So that's another one. And then the third answer is the L1 continuing to be able to like do more and continuing to be able to support applications. So historically, like there have been attempts to increase the gas limit, but a lot of core devs are against it. I think the thing that I'm in favor now is not across the board gas limit increases, but like targeted increases to specific forms of computation that we know can be done safely. So like there's pre-compiles that you can do cryptography more efficiently, which would benefit both layer 2, like based rollups, and it would also benefit layer 1 based privacy protocols. You can reduce the gas costs of like specific kinds of EVM computation. You can potentially reduce the gas cost of logs. There's like this entire array of things that you can do, right? So I think it's, and then also you can make the L1 like actually more useful for applications. For example, you can try to do some research to try to bring the slot time down even further. So I think it's like some combination of all three of those.
So you have time now, probably 1 or 2 questions I would like to give to NTU students or professors, businesses, academic event.
Hello.
Prof, you'll be the next.
Hi, thank you for your talk. I think I'm a believer for the decentralization, but at the same time, I think it's a lot of resources are kind of wasted, right? So at the same time, I think you're talking about AI. AI is a highly centralized, and I think one direction is to make it decentralized. And AI also consumes a huge amount of resources, computation. So there's an idea as can you change proof of work or proof of stake to something like a proof of use for training, so that you can make use of the resources that consumed in training. This is going to be pervasive, I guess. But I think there's a lot of things like certifies how to make that the fidelity of the training results, etc. So, but do you think that's something possible?
Yeah, I think that's interesting. The challenge with proof of useful work historically has been that it's always been hard to identify any specific category of useful work that could actually scale up to a very large size, right? Like people tried to do like proof of folding at home, but it was always like either hard to verify or like people figured it out, and then like 2 years later AlphaFold basically solved it. And the challenge with AI is that AI is this fast-moving sector, and like we don't even know if 2 years from now LLMs are going to work or be trained in the same way, right? Like maybe, I mean, even if you think about like the details of how transformer architectures work, right? Like there's been advances in like how attention works that can allow much longer context windows. There's been the whole shift toward like 4-bit models, and then you have 1.58-bit models, and you have like specialized forms of training for that. Like basically, and the challenge is that if you're a centralized service, if one of these things change, like your engineers can just go and change it in 2 hours. If you have a blockchain, changing it requires an entire hard fork, right? And so basically, if you try to do like AI training inside of Ethereum, then basically every single hard fork, you need to have like an entire section of governance dedicated to replacing the entire like training algorithm with something else, right? So like that's historically been the challenge.
Okay. One last question for Professor.
Thank you. In our everyday life, a lot of our personal information is centralized with banks, insurances, governments, and so on. And typically people trust those institutions, so there are advantages to centralization. We know who's responsible. where do you think decentralized systems will be the first ones in the first sectors to replace them, where they solve enough of a pain point that actually decentralization is an upside, other than just having a really interesting and great technology? Most people maybe, they care not so much about that, but where does it solve a pain point that we can help when we decentralize it?
Yeah. So I think in the context of finance, like we kind of know the answers already because we can look at like where crypto is being adopted and used for payments, right? Basically, a big part of the answer is obviously like international payments, and a big part of it is like savings and payments in the context of countries and environments where the centralized institutions like actually don't work well at all, right? And we do consistently see quite a lot of uptake in those areas. So I think to me that's one part of the answer, and like that's just in the case of finance, right? I think if you want to go beyond that, I would say like I would also say it's an illusion that like our level of trust toward these institutions is infinite, right? Because like there is a lot of personal data that just does not get used, does not get uploaded because there is no way to safely use it in without actually like trusting even more, right? Like like in Europe, there's like laws that it's like in a lot of contexts illegal to like export customer data outside of Europe, right? And like there's a lot of those types of trust barriers. That's less of a blockchain thing. That's like more of a cryptography thing, right? But if you have cryptography, then you actually do have ways to like get specific bits out of data that we're actually not like actually taking advantage of at all right now, but at the same time do it without taking those risks. So I think even in relatively high trust environments, there's still opportunities to like get more economic benefit by by like adding even more of this kind of trustful technology. I mean, one other example, right, is like a lot of the time it's about enabling more market competition, right? It's like people are willing to trust, like a Google or whatever big company, but are they going to as easily trust a startup that like just immediately pops up to try to compete with them, right? Not necessarily. And so if instead we create a tech stack by which startups can provide the same quality of service, but do not require themselves to be trusted, not like one type, either for data or another type of trust is just trusting that they'll exist in 10 years, right? Like if I want to build an application and I'm gonna, and my application plugs into your application, like I would feel more confident if I have a guarantee that the thing will exist in 10 years, and startups can't provide that by default, but smart contracts can. So like on a lot of those dimensions, I think enabling more market competition is another value add. Though I do think that like the larger value add is still in like the the parts of the world and the contexts where the level of existing trust still is like quite a bit lower than what some of us are used to.
Thank you.
Okay, thanks for talking again. So
Now I'd like to invite Prof. Now I'd like to invite Prof. to present Vitalik Buterin with a token of
do
appreciation.
not wait. I will invite Vitalik back to the seat, and we'll have a group shot and then post on our website. So you'll have a copy. Okay. Wait for our official photographer to do that. Two ways. Okay. You maybe stand a little bit up.
Hey, you can see her. Okay, 1, 2, 3. 1, 2, 3. 1, 2, 3.
Okay. We come back to the seat and have a group shot.
One more. 3, 2, 1. Last one. 3, 2, 1.